Yeah.
the time.
So in the second book, actually, maybe you may be starting with alkyl and aryl halides of organic chemistry. That is the chapter which is complete in almost all of the schools of remaining schools. So can we have just a bit of discussion regarding that? Just a very little discussion.
Okay.
Okay. So let me start with a general discussion and yeah. Okay. So the topic is alkyl and aryl halides. That is the first chapter of the next book. Okay. Second book too.
Okay,
Yeah. So what do you mean by alkyl and aryl? What does this name means? There is another name also. Okay. Alkyl or it is also known as haloalkanes. Right. And this is haloarenes. Right. This is also a name. They are also famous by this name. Both are used. Alkyl and aryl halides or haloalkane or haloarenes. Okay. What do you mean by the term halo? What do you mean by this term? Halides or halo? What does this indicate? Yeah, we have halogen group in the periodic table, right? And it is group 17. Okay, and just the last group is of halogen noble gases, helium, neon. Okay, just adjacent to that. Okay, the second last group on the right hand side is halogen group, and if you look at the element in it, you have fluorine, chlorine, bromine, and iodine. Though there are two more elements below them, but we don't consider them. So these elements are known as what? Halogens. Right? And what does this mean? Halogens means salt forming, and they are the part of salts. Okay, many salts, many ionic salts have these. For example, we are aware of the sodium chloride, which is common salt which we use in our home for cooking and all in the food. That is NaCl. You have KCl, right? NaBr, Ki, right?
What is the full form of KCl?
What's the full form of?
KCl.
Potassium chloride. Okay. Right. So these are halogens. Okay. So what do you mean by, so we have halides or haloalkane or haloarene. What do you mean by halo? Halo means chlorine, bromine or iodine. Okay. It can be any of these. Okay. So this is potassium chloride. So potassium is the metal. Okay. And these are the halide ions. Okay. Negatively charged ions. So these are actually present in the salt. That's why the name halogens. Okay. And suppose if they are connected to alkanes, so tell me which is the smallest alkane, you know? Yeah, alkane have carbon and hydrogen, and the smallest alkane is what? Methane. Okay, which is having only one carbon. And the carbon can make 4 bonds, so I need to connect 4 hydrogen. Okay, this is the alkane, smallest alkane, methane. Okay. And if I remove the hydrogen atom, and if I put a chlorine atom in place of hydrogen, okay, because carbon can make only 4 bonds. If I need to put chlorine, I need to remove hydrogen. I can't connect hydrogen without removing any of the group, right? Carbon can make only 4 bonds. Okay. Do remember this, everywhere it will be useful. Okay, so H, 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 and Cl, right? So this is this molecule which is formed by removal of H and putting Cl or a halogen, any of these halogen in place of hydrogen, right? What you get? You get haloalkane. The general name is haloalkane, means there is a halogen and there is an alkane, right? And this is the general name. And what will be the specific name of this haloalkane? And this is chloromethane, because this is chlorine, Cl is the chlorine. Okay, is it clear?
Yes.
So what is the general way of representing haloalkanes? The general way is to write them as R X. So alkane doesn't necessarily mean there will be only one carbon. There can be two carbon, there can be three carbon group. Okay. So in general, we say it as R. Okay, R means any alkyl group. And X is the halogen, right? It can be fluoride, chloride, bromide, or iodide, which we have seen over here. Okay. Correct? So this is another example of a haloalkane is this one. Okay, there is a alkyl group and there is a halogen group atom attached to the alkyl group. So this is another haloalkane which is larger in size as compared to chloromethane. So what's going to be the name of this? Can you try? Or both of us can try. So this is bromine, right? And it is known as bromo. And which alkane is it? Tell me. Which alkane is it? It is the alkane having two carbon atom. Okay, so one carbon atom it is methane, two carbon atom is ethane. So it is bromoethane. Okay, clear?
Yes.
So similarly, you can have, you need to remember the word root. Okay, so for example, if you have only one carbon atom, this is methane. If you have two carbon atom, always remember that carbon make four bonds. So accordingly, put the number of hydrogen atom. So always keep in mind that the total number of bond, including the between the carbon and with the hydrogen or with the halogen, should not be more than 4 on any of the carbon atom. This is ethane. And if you put a bromine here, this is bromoethane. If you put iodine, but you need to remove H. That's what I told, because you can't make more than 4 bond. So minus H and plus I. If you put iodine, so this is going to be ICH2. This is a condensed way of writing, and that was a detailed structural formula. This is condensed. I don't show the bonds. I write the number CH3 means 3 hydrogen are there. And this is iodoethane. Okay. Is it clear?
Yes, sir.
So likewise, you can have various haloalkanes. The halogen can be fluorine, chlorine, bromine, or iodine, or alkane can be methyl, ethyl, propyl, butyl, for 1, 2, 3, and 4, or more than 4 also, pentyl. Okay, we will go through their names. Don't worry, right? So accordingly, you will have different haloalkanes. Okay. Now let's have some introduction of aryl groups, aryl, halide or haloarenes. So what do you mean by aryl? Any idea?
Mean of
Yeah, aryl. Any idea? Any guesses? Or I will give you one hint. What are aromatic compounds? You know, aromatic groups. And which is the most common aromatic group? So which compound is this one? So are you familiar with the bond line representation? Just tell me if something is not clear. Feel free to discuss with me. Okay. So don't worry about the. If you don't know, just ask me. Okay. It is a very simple thing. Okay. Even I also don't know many new things. Okay, which I read new books. Okay. So I refer various other internet and other things. Okay. So don't worry about that. Right. So this is which compound I have written here. And actually the detailed structure is like this. Okay. Actually, what is there that we don't write the carbon and hydrogen in order to save time? Because if we write the complete structure, it is like this. And you can check, this is the carbon atom, intersection of two lines is the carbon atom, and if there are two parallel lines, mean there is a double bond. Like this, there is a double bond, there is a double bond, there is a double bond. Okay, this is the short form bond line representation, and that one is the detailed structural formula. This is bond line, and that is the detailed structural formula. And what is the name of the compound? It is known as benzene. Okay. So where do we use benzene? Any idea? Or any compound similar to which contain a benzene ring? Actually, so we use phenol. Okay, phenyl, which we call phenyl for cleaning purpose. Okay, household disinfectant. We also put one other aromatic compound, which is not benzene, but which is made up of two fused benzene rings. This compound you might have, I'm sure that you might have seen this compound. This is also aromatic compound, and this name is naphthalene. We put naphthalene ball in the various places. Okay, they have a peculiar kind of smell. Okay, in the cloth also we put, in winter cloth most of the time, when we are keeping them for some days without use. Okay, so this is naphthalene. This is also aromatic compound. So aromatic compounds are actually made up of benzene rings. Okay, and if you remove any of the hydrogen, and if you put any halogen atom, that is aryl halide. Okay, is it clear? Yeah, for example, in the benzene, if you remove hydrogen and if you put chlorine, that is what? This is chlorobenzene. Okay, clear?
Yes.
Okay, this is an aromatic compound. So general aromatic, just like alkyl group is denoted by R, and halogen, general way to denote a halogen is X. So similarly, you put AR for aryl group and X for halogen. It can be FCl, BRI, Aryl group can be benzene, naphthalene, but most benzene is the most common, so it is mostly benzene. Okay, there is also one more way of representing it, that is PHCl. Okay, this PH is a phenyl. It is also known by the name of phenyl. Okay, benzene ring. Okay, and chlorine, chloro, the halide. Okay, so this is what the name means. Okay, so this is the general introduction. And another thing is, how do you prepare, let's say, smallest compound of alkyl halide, which is, let's say, chloromethane? How do you prepare it? How you are going to prepare it from the methane? Any idea?
Sure.
Yeah, actually, what you need to put Cl. Okay, so Cl, what is the source of Cl? Most common, you take chlorine. Okay, and when you take chlorine, on its own, it is not going to react. Okay, because they are connected to each other. The methane also, the carbon and hydrogen are connected to each other, so the reaction may not happen on its own. So what you do, you need to provide some energy, and energy you provide in the form of light. Okay, UV light. And the you might have studied in class 11, the energy of the photon of the light is h into frequency. Okay, so you put some UV light or sunlight, you put on this mixture of reaction, you mix them, and you put light, or you can use heat also. So what happens is, their bonds break. Okay, and the reaction start happening. Okay, clear? And the quick way to do it, this is, just remove HCl and join CH3 and Cl together. Clear?
Yes, sir.
Yeah. So this method for preparation of alkyl halide is known as, you are using light, you are using the photons, the particles of light are known as photons, which are the carrier of energy. So you are using photons or light, so that's, and doing the halogenation of alkanes, means you are connecting halogen atom to the alkane by usage of light. Okay, so this is known as photohalogenation. This is photohalogenation reaction. Okay, so you need light, okay, of reaction for alkanes. Is it clear or not?
Explain it again.
Pardon?
Last, last one.
Right? Clear? And what happens if you keep on reacting it? Yeah. Suppose if you take first time, it is, you are going to get CS3, Cl and HCl. And CS3, Cl, if you react it with more chlorine and sunlight or UV light, what is going to happen? What is going to form? How you are going to write the structure? Yeah, tell me. Yeah, just write. So think what we did here. We removed one H and we removed some one chlorine from Cl2. So same thing we are going to do it again. Okay. We will remove H from CH3Cl and one Cl from Cl2. Okay. So and that is going to become CH2Cl2. Now we have two chlorine atom and HCl. Okay. So if you react further, CHCl3, if you react with the third mole of chlorine, you are going to get HCl, CHCl3 and HCl. This was chloromethane. We discussed it. And this is dichloromethane because there are two chlorine. And this is trichloromethane. Okay, there is also another name for it, and that is chloroform. And if you react it with more chlorine further, the final answer is going to be CCl4. Right? This is going to be the final answer. Now, no more further reaction with chlorine is possible. Every time you need to write HNu or UV light or sunlight, okay? Because it will not react until unless you provide some energy, you provide some heat. The bonds are not going to break and it is not going to react. So for reaction to occur, you need some energy. You need some sunlight, okay? Or UV light to break the bonds of chlorine. And that's how it happens. Okay, so this is photohalogenation reaction of methane. And this is known as the monochloro derivative because you have put one Cl. I will write here. And this is dichloro derivative. This is trichloro derivative if you have put 3 Cl by removing 3 hydrogen atoms. And this is tetrachloro derivative. Means you have put 4 Cl groups, okay, in place of hydrogen. Right? Clear?
Yes.
So, but you can do for larger alkanes also. Okay. For example, let's go for ethane. And if nothing is mentioned, you are going to write only monochloro derivative. So how many monochloro derivative are possible for ethane? That you can tell me. What I mean is, I want you to connect one chlorine on this whole molecule by removing one hydrogen. And how many different ways it can be done? It can be carried out. Yeah. Yeah, tell me. And so you need to look, you need to, I'm asking, you are putting one chlorine in place of one hydrogen. and in how many different ways it can be done. That's what I'm asking. Okay. So what you need to check? You need to check how many different types of carbon atoms are there. Okay. Here you are having two carbon atoms, but both are same. Right? Why they are same? There are two carbon atoms, but both are same. Because if you write the molecule like this or this, it is one and the same thing. It will not change. So you can put Cl either on this carbon, but if you put Cl on the left carbon, this is not going to be a new product, right? This is both are same. Why they are same? Because if you change it like this, if you bring it like this, okay, you can write it like this. Okay. If you turn it like this, the Cl will come on the right hand side, and both there are only two carbon atoms, both are same. And this is one chloroethane or chloroethane, and this is also one chloroethane. Because you start your numbering from the carbon atom which is nearest to the side chain or the substituent. Is it clear?
Can you explain again?
Yeah. Suppose, yeah, I will explain. Actually, you suppose someone may say that it is two chloroethane and this is one chloroethane. This is one and this is two. First carbon, so this is one chloroethane. And this is two chloroethane. Is it so that it is two chloroethane? No.
No.
It is same as one
Same.
chloroethane only. Okay. Because this numbering is incorrect. You need to start your numbering from the carbon atom which is closest to the substituent or the side chain, right?
Yes.
Yeah. So both are one chloroethane and there were only two carbon atom and both were interchangeable. So both actually gave the same product only. Okay. So ethane is going to give you only one monochloro derivative. Okay. What will happen for butane? Butane is having four carbon atom, and this is the condensed way of writing butane. Okay. Just I have kept in mind that all carbon are connected to four bonds. Okay. And if I ask you to write the number of different mono-bromo derivatives. Mono-bromo derivatives by reacting butane with bromine in the presence of sunlight, you need to write how many mono-bromo derivatives can form. Means mono-bromo means you are allowed to put only one bromine. So how many mono-bromo derivatives are possible? Yeah. So what are the you need to think that what are the different, there are four carbon atom and are all four of them different or same? Some of them are same. And you need to think that what are the, you need to put only one bromine because I am asking total number of mono-bromo derivatives. Formed in the reaction. Total number of mono-bromo derivatives formed in the reaction. So how many mono-bromo derivatives are formed in the reaction? There are 4 carbon atoms. Are they 4 or just 1 or just 2 or 3? Yeah. Yeah, Mohammed, you can give it a try. How many will form? You need to connect only one bromine. So what I did, I connected bromine to the left carbon. I connected bromine to the second carbon, right? I connected it to the third carbon from the left. So are all 4 of them different or same? Yeah, tell me. You can write their IUPAC name also. Yeah. They are same or different?
Different.
Yeah, they are different, but some of them are same also. So I will do the numbering from the end which is closer to the side chain. This is the side chain or the substituent, the group which you attach. You need to do the numbering so that the group which you have attached get the lowest number. So I started my numbering right from this point 1. So this is 1 bromobutane. Okay. And if I do the numbering in this way, which is the right way, this is 2 bromobutane. Okay. Because the bromine is connected to second carbon. And what about this one? Is it 3 bromobutane?
No.
Yeah, no. We need to do the numbering such that the side group is get the lowest number 1, 2, 3 and 4. This is the right way of numbering. So this is again 2 bromobutane and this is 1 bromobutane. Okay. So they are same actually. So how many different structural isomers? Isomers are the compound having same formula but different structure. They are having same formula because they are having 1 bromine connected to them. Okay. So same formula but different structure. So how many different isomers you obtain by doing the bromination of butane? 2. 2 structural isomers you got. Is it clear?
Okay.
2 different compounds. Okay. So likewise, this is the preparation. This is the basics of that haloalkane and haloarine. Okay. This is the chapter. There is IUPAC naming also. In electrochemistry, which you are doing in the school right now, you may be having holidays, right?
Yes.
So in electrochemistry, till which point it was covered? Nernst equation.
Stop in
You completed Nernst equation or left?
electrochemistry.
Yeah. And after Nernst equation, there you have electrolytic conductance and electrolysis, Faraday's law. That I think you might not have done, right? Till now in the school, or is it completed?
of in self potential and gives energy.
Hmm. Okay, so let's discuss it more today. We are running out of time because it was just a small class. So let's discuss the more detail. We will continue with this chapter, or if you want me to start a new chapter, we can continue with this because the moment your school open, you will have this chapter first completed. Okay, and we can take the chapter which you want, like solutions or electrochemistry. Okay, that also we can cover it up, right?